Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the isometric projections involving the combination of solids. In this problem statement, we have a sphere of diameter of 50 mm resting centrally on a cube of sides of 50 mm. So we need to draw the projections of the combination of the solids. Before we start, let us understand the problem statement. So here we have got two different solids. One solid is a cube whose sides are measuring 50 mm, and also the next solid here is a sphere whose diameter is 50 mm. So with this data, let us see how to do the isometric projection of the combination of these two solids. So before we start the isometric drawing, let us draft the orthographic projection of the combination of the solids. So let us begin by selecting the line option. Select a line of thickness 0.18 and draw the reference line which is having a thickness of 0.18 mm. So now we shall complete the top and the front views of the combination of the solids. So select a line of thickness 0.13 and go for the rectangle by center option and select any arbitrary point which marks the center of the rectangle. So we'll enter the dimensions. So the dimension of the cube here is 50. So enter both the length and the width as 50 mm and we get a square. Or rather, you can construct this entire square using a line of thickness 0.50 mm because it is completely visible in the top view. So this marks the square of side 50 mm because the cube is going to appear as a square of side 50 mm in the top view. So now we shall go for constructing the next solid. So we need to understand that there is a sphere which is resting on the center of this cube. So for that, go for circle by center, select the thickness of 0.50, and when you move the cursor, you can just select the midpoint. So for that purpose, just go for the midpoint option in the IntelliSketch. So the midpoint of this edge and also the midpoint of this edge. So you get the center of the square. So in this point, you can just keep a circle of diameter 50 mm. So this is the top view of the combination of the solids. So now go for the line option again and let us complete the front view. So draw a line of thickness 0.13 which marks the projection lines. Also, from the center of both these solids, draw a line so that we get the center line. So now here we can draw the front view. So in the front view also the cube measures 50 mm. So the axis will be equal to 50 mm. So since this is the axis line, we can select the line and change the type of the line to the axis line. So this marks the center of the cube. So select the line option again, continuous line of thickness 0.50. So from this endpoint to this endpoint, the base of the cube followed by the front view of the cube which appears as a square again of 50 cross 50. So this is the front view of the cube. So again we need to understand here that we need to place a circle which is nothing but a sphere whose diameter is 50 mm. So again go for the line option, select the line of thickness 0.13, select the center line. So from here we need to draw the center line of the sphere. So since the diameter of the sphere is 50, the radii will be equal to 25. So drop a line of thickness 0.13 to mark the center of this sphere. So now go for circle by center point, select continuous line of thickness 0.50. So keeping this point, end point, as the center point of the circle, draw a circle whose diameter measures 50 mm. So this is the sphere. So this is how the top and the front views could be drafted. So go for the smart dimension and show the dimension of this particular sphere whose front view appears as a circle as 50 mm, and this is the front view of the cube whose side is measuring 50 mm. So go for the annotation and annotate the reference line as x and y and also the planes as VP and HP. So this marks the first step, that is to draw the orthographic projection. So now we need to convert this into the isometric. So what we will do is we'll go for continuous line of thickness 0.13, draw a reference line. So from any arbitrary point, let us just keep the center point off for time being. So from any arbitrary point on this line, let us draw the base of this cube whose side is measuring 50 mm. So let us start from this end, 50, and we do know that all the lines are inclined at an angle of 30 degrees to each other in case of a isometric projection. So the angle should be equal to 30 and the length should be equal to 50. So this length will be equal to 50. So go for the line option again. So from here again, construct a line of length 50 and the angle should be equal to 150. So next, again the length of the line is 50. The angle will be equal to minus 150. So just extend this line. So change the dimension to 50. So this becomes 50 now. So go for the line option again. So again, when you join these two endpoints, you can just see that the angle is minus 30 degrees. So as per the rules of the isometric projections, you can just see that each lines are making an angle of 60 degrees or 120 degrees. That is the interior and the exterior angles. So this is the first part, that is the base of the cube, which is equal to 50 mm. So in the isometric sheet, you'll be having 5 boxes joined, and that completes the base of the square prism. And next thing is we need to draw the height. So for that, again select the line option, and from each of the corner points draw a line of length 50 mm. So this is again 50. So in the ISO scale it is 5 boxes. So each box will be measuring 0.816. So again from here 50. So now we can just connect the endpoints of each of these lines to complete the top face of the cube. So this completes the cube whose dimension is 50 cross 50. So now from here we need to identify the center point. So just draw the diagonals so you get the center point. So this is again the diagonal line whose line can also be considered as the edge. So from here, the point of intersection, let us draw a line of length 25 mm. So which is coming till here. So this is the center point of the sphere. So now we do know that this is as per the true dimension. This is not the ISO dimension. You can see here this is 50 mm, this is 50 mm. So this is in the true scale. So now we have to convert this into the ISO scale. So what we can do is we can select the entire object that we have created, and there is an option called as scale beneath the mirror option here. So here we need to enter the value of the scale. So we do know that the relation between the true length and the isometric length is 0.816 times. So 0.816 times the true length is the isometric length. So this is 0.816. So just ensure the copy is off and then place this object. So you can just see that the scale has been reduced. So now uh, in the manual construction also, to construct the sphere, we will draw a circle of true radii. So we have marked the center point here. So keeping this point as the center, just draw a circle whose diameter is equal to 50 mm. So this completes the combination of the solids. So but we do know that in the isometric projections, none of the hidden lines will be seen. So you can just go for the trim option and trim these lines. The construction lines and the hidden lines will not be seen. So you can just trim these, and the circle should be equal to the true scale. It should not be equal to the ISO scale. So just convert the entire cube into the ISO scale and then draw a circle whose scale is equal to the true scale. So that is 1:1. So go for the selection of the entire isometric solid and then just change the line width to 0.50 mm. So this completes the projection, the isometric projection of the combination of the solids. So you can just go for the angle between, show the dimensions. So this will be equal to 30. So each line in the isometric sheet is inclined to 30 degrees. So you can just show this particular dimension. So go for the smart dimension. See here, it has been converted. So 50 mm in the true scale has been converted to 40.8 mm in the iso scale. So that is 0.816 times the true length. So in order to show the length, what we can do is just unlock this dimension option and enter this as 50. So this underlined dimension shows that it is an edited dimension and not the actual dimension. So go for the text and you can insert ISO, indicating that this is the isometric dimension of 50. And also go for the sphere, and this is equal to 50 mm. So go for the annotation, and this is the true dimension. So this is the true length of 50 mm. Again, go for smart dimension, show this dimension which is equal to 40.8. So just select this, unlock, enter 50. So this is showing it is a over written dimension. So this is the isometric 50. So ISO 50 stands for 5 boxes in the actual sheet, the isometric sheet. And also if you just go for the circle, you get the center point. So select a line of thickness 0.13. This is only for the construction purpose we are showing. It is not to be shown. So this is 25 mm. So this dimension, you can just go for the smart dimension, and this will be equal to the isometric 25 mm, the distance from here whatever we have taken, that is including this point. So these are the dimensions to be shown. But however, again, in the isometric dimensions, we are not showing any of the dimensions also. It is only for the learning purpose that I'm showing the dimensions here. That is ISO 50, that is the width and the height of the cube, and the true radii of 50 mm, considering a height of 25, which is again equal to the isometric dimension. So in order to understand that, let me use a line of thickness 0.13 and simply extend this line at an angle of 30 degrees. And again extend this line also at an angle of 150 degrees. So you can just see that they're all meeting at the center of the circle, and this dimension will be equal to ISO 25. So go for the line option, point of intersection to this. So this will be equal to ISO 25. So this is how we create the combination of the solids in the Solid Edge software. So with this, we complete the video wherein we have shown the isometric projection of the combination of two solids, that is a sphere which is resting centrally on the top face of a cube whose dimension is 50 mm, and also the diameter of the sphere is 50 mm. Thank you all for watching.